Module 2.4, Pendulums. Another simple vibrating system is a pendulum. A pendulum is simply a suspended mass that is free to swing. Examples of pendulums are clock pendulums, a child on a swing, and an old-style metronome. As it so happens, there is a formula for the frequency of a pendulum. F equals 1 over 2 pi times the square root of g over L. Does this look familiar? It should. It's very similar to the spring mass formula. For the pendulum formula, F equals frequency, g is the acceleration due to gravity, and L is the length of the pendulum. The big picture. What does this formula tell us? Frequency is directly proportional to gravity. So, if we decide to go to the moon, gravity is 1/6 of Earth's gravity. Since g is lower, a pendulum's frequency would be lower on the moon than it is on Earth. But since we're only going to be on Earth, we'll generally consider g to be a constant, and that's 9.8 meters per second squared. The formula also tells us that frequency is inversely proportional to length. As length increases, frequency decreases. Here's a little device I created to show the effect of length on a pendulum. Which paperclip will have the highest frequency or move back and forth the fastest? If you guessed the short one, you're correct. Shorter length equals higher frequency. If we are looking for the period, you can flip the equation the same way we did with the spring mass formula. So period equals 2 pi times the square root of L over g. Also, since it is a square root relationship, just like with the spring mass system, any change in g or L will result in a change that is the square root of the change. Here's 2 questions for you. What do you think would happen to the period if you increase the distance the pendulum travels? How do you think the period would change if you increase the mass hanging on the pendulum? Pause this video. On the module page, do some simulations yourself. Then restart this video. Welcome back. What does the formula say about mass and displacement? Neither displacement nor mass are in the equation, so as you should have seen, neither will cause a change in period or frequency. To review, a pendulum is a suspended mass that is free to swing. F equals 1 over 2 pi times the square root of g over L, where F is the frequency of vibration in hertz, g is the acceleration due to gravity, and L is the length of the pendulum in meters. F is directly proportional to gravity and inversely proportional to length. T equals 2 pi times the square root of L over g. Displacement and mass do not affect frequency or period.